Okay, we're still messing with pH because acids and bases are pretty much everywhere, right, in our world and with what we do. So we've talked about strong acid solutions. You just took a quiz on weak acid solutions. Now we're going to be talking about weak bases. So if you have a weak base in solution, I guess, Connor, the pH is going to be less than what? You come up with all these homework questions for, oh, here's a weak base, and we're going to put it in water. You better come up with a pH number less than 7, right? All your answers. Otherwise, it's not a weak base, right? It doesn't matter the concentration. If it's a weak base, man, it's going to have a basic solution. Okay. So let's start out with, how do we recognize, Mia? Where'd she go? Okay, Alyssa. Alyssa, how do we recognize a solution of a weak base? What do you think? It's got to be in the table, right? So that's what we're handling today. It's got to be in the table. Next class period, we'll handle a whole new class of them. But the point is, right now, they got to be in the table. So you put any of these compounds in water, and it's going to be a basic solution. Okay? And notice how in this table, look what they're giving us. Our equilibrium constants. Now, the equilibrium constant, Kenneth, has a little subscript on it. What's the little letter on that subscript? Kenneth? A little b. Probably for what? Anybody? Base. Yeah. Okay, now, a funky thing I think about these equilibrium constants is that whenever an equilibrium constant, a big K, has a subscript, you have to write the reaction in a certain way. And if you don't write it in a certain way, forget it. That number's meaningless. You're going to get totally wrong answers. So we have to, for example, we had K, just to remind you, we had Ka. And we had all these tables, right? And that's only if you wrote the reaction as what goes to what. If I said my acid is HA, it would go to H plus and A minus. You had to write it that way. Otherwise, it didn't make any sense. Okay? So likewise with these KBs, these base ionization constants, or hydrolysis reactions, because it's just a base reacting with water, pretty much. Okay, so how do you write these? You have to have the base in the table. So you pick one, right? I don't know, this funky guy. Right? So any base in the table. Okay? But the point is, it's going to react with what? Water. And it's going to produce, let's see if someone saw this, Enrique. OH negative, right? Because remember, it's got to be a basic, so it's got to produce these guys. And the acid. Oh, what's the best word for it? The technical word to sound like you really know what's going on. The what acid? Dang, Enrique. The conjugate acid, right? So, we should put subscripts on these so we know what shows up and what doesn't show up in our equilibrium constant expressions. But Anessa, let's just go ahead and see if we can write this. Let's get rid of this. Okay, get rid of that too. How should we write the equilibrium constant expression? Kb would be concentration of OH negative times the concentration of that conjugate acid over the concentration of that base. Yeah, good. She left out the water, right? Because we should have a what subscript on this? Mia, what subscript should we have on the water? A little L. All right. AQ on the hydroxide. Okay. AQ here. AQ. But we just get lazy, right? But we should be putting those in. Okay. So Mia, where are these KB numbers? This is what you get for stepping out. They are all, let's help her out. Where are all these KB numbers? These KB values? You guys need to start sitting up front. They're in the tables, right? Because these are the only bases that we have. You got to get this stuff from the tables, right? So that's how we're going to recognize a weak base. It's just one of these. Okay. Let's practice a few of these. So go ahead and you see the format, how to write the reaction, the base ionization reaction. Go ahead and write it for ammonia. And then write the corresponding equilibrium constant expression. Write the base hydrolysis reaction, or the base ionization reaction for ammonia. What does ammonia do when you put it in water? It's in the table, so it's a base. Okay. Audrey, what did you write? What plus what gives what plus what? NH3 plus H2O. Perfect so far. Goes to OH negative. Perfect. All right? Excellent. You recognize you have to add an H plus to get the conjugate acid. Okay? And let's see. Oh, we need the KB expression. Oh, Steph, how would you write that?
KB equals the concentration of OH times the concentration of NH1 over NH3 concentration.
Perfect. All right, products over reactants. Leave out pure liquids and solids. Okay, so here we go. Find the hydroxide and the pH of 0.01 molar. What is that? Pyridine? C5H5N? What's the name of that? Yeah, pyridine. Oh, we're going to need that number, aren't we? 1.4 times 10 negative 9 for pyridine. Did I give it to you? Yeah, I gave it to you. Find the hydroxide and the pH of 0.01 molar pyridine. Jose, you got a game plan for this? Anybody got a game plan for this? What would we have done if it was a weak acid? You just did it on the quiz. But what did you do? We did ice, right? Of the Ka reaction. Well, now we'll probably just do what, Kendall? Ice of the what reaction? Not the Ka, but the Kb reaction. So it's very, very similar. Same game. Oh, you should be really happy to see that exponent, right? If you remember this. So write the Kb reaction, do ice. See if you can get your answers out of this. Right, the Kb reaction, and let's do ice. Because they want the answers at equilibrium, so you have to do ice. And we have to write the Kb reaction because they gave us that particular equilibrium constant. Let me interrupt you for a quick here. Kendall, how did you write your conjugate acid?
At the bottom of there, I just put A5, H4,
Yeah. So we have to add a what to get the conjugate acid? Add an H. Add an H plus. And so you could write C5H6N plus, or I kind of like, that's probably how folks would write it, but I kind of like putting the H out front because then I can recognize that I can recognize easier that it's a conjugate acid. But notice how it really doesn't matter if you get the formula right or not in the math, because the math it's not going to influence the math. Okay. See if you can get an answer for this. Andromeda, is that how you filled out the ice table? You agree? Okay, so what'd you do with those numbers then? What'd you do with that ice table? Okay, so the KB was 1.4 times 10 to the negative 9. So that means you made it equal to what over what? X squared
over the 0.01.
Yeah. Great. Okay. So Connor, did you get this far?
Yes.
All right. So what'd you do next then?
Well, that equals 0.01.
That equals 0.01. And why?
Because if you do the math,
You get the same thing. And the math all depends on that exponent, right? What was the magic number that you wanted, that you're looking for these exponents so that you can play this game? 10 to the negative 4 or smaller, right? 10 to the negative 5, negative 6, negative 7, negative 8. Great. Okay. Mia, did you bring your calculator? Fantastic. So what'd you get for x? 3.7. Oh, I'm glad. Did you hear everything she said? She said 3.7 times 10 negative 6. And she recognizes that's for the OH. Right, because you look at the ice table. That's not your H plus. Before we just took log of our x and we got our pH. But now you take log of your x and you get POH. Subtract from 14 and you'll have pH. Everybody get 3.7 times 10 negative 6? Fantastic. Okay, good deal. So there's our hydroxide. So what'd you get for your final answer for pH then, anybody? 5.4? 5.4, Jose? 8.5. Well, it needs to be what? Basic. So it better be, basic is above 7. So it needs to be above 7, otherwise you're in trouble. What'd you get? 8.57?
Well, yeah, but then you have to
X is for both OH and for the acids?
Well, X is OH. If you wanted to mess with the acid, then you're going to have to do a whole Ka reaction. Right? So no, we did a Kb reaction because we have a base. We know X is that, so we could show all of our steps. So that means POH. Right? 3.7 times 10 to the 6 negative. POH is 5.4. So 8.6 or so, 8.57.
Yeah, so that's what you used that front of
Okay, so okay with that? You should have got about 8.57 as a final answer. The 5.4 was POH, all right? Okay. So try it again. Try it with this EX3. If you didn't get this one, let me help you out. But try EX3.
So is that the part where you get the OH, then you get pH, and then
So you take the log of this. See what there's two ways to do this. If you know this is hydroxide, you can put it into 1 times 10 negative 14 equals hydrogen ion times hydroxide and solve for hydrogen ion, then take the log of that. But it's kind of easier, since you already have this in the calculator, just take the log of this, because that's POH, right? And so POH is 5.4. And then pH plus POH is 14. So since it already has a negative sign on it, you can just add it to 14, because that's subtracting it. 8.57, yep. So if you get an answer for 3, let me know, and we'll see if we can get a consensus. Then go on to the next one. Did you get an answer for 3?
Yeah.
pH of 11.68, 11.7.
Yeah.
Anybody else get 11.7 as a pH? Okay, great. 3 people got it. So for this number 3, see if you can get a pH of 11.7. If you did, man, you're on the right track. Go on to the next one. If you're not getting it, man, just ask. It's either me or someone can help you. Oh, you don't have your booklet. Well, I can get it. There, it's all there, Kendall. Okay, so for number 3?
For 4.
Oh, for 4. Okay. You know, you could, but you don't have to.
There's a trick.
There's a trick.
Go
You know the trick. Because if I wouldn't have said bases, if I would have said acids, and you have this nice big table, what did we go by? The K. Yeah, if it's acids, you go by Kas. If it's bases, you go by Kbs. So the bigger Kb is, then the weaker or stronger that base is.
Oh, this is the lowest.
Right?
We knew that one.
So you'd go by, so what's the answer? If you go by the bigger or smaller the Kb, the stronger the base. Which one?
Wait, what? The bigger or smaller?
Yeah.
Smaller? Smaller the KB?
The smaller the Kb, the stronger the base? When the Kb reaction, what are the products? OH. So the more O, and all Ks are products over reactants. So Ks, the more product you have, the bigger the K. And if you want to be a strong base, you want a lot of product. So big KBs, big strong base. Just like KAs, because KAs always produced H pluses. So if you want a strong acid, have a really big Ka. Is anybody not getting number 3? Did you get number 3, Jose? All right. Then we need a game plan for number 4. And Alyssa has a great game plan. What's the game plan? Say louder. The bigger the KB, the stronger the base. Just like KAs. The bigger the Ka, the stronger the acid. But these are all bases, so we need a base table, a base ionization, a KB table. And you have one on the first page. In fact, what are these? Megan, you're looking at that table. Let's just go ahead and write these down right away. What's N2H4's KB? 1.7 times 10 to the negative 6. 1.7 times 10 to the negative 6. Then ammonia?
1.8 times 10 to the negative 4.
Okay.
Sorry, 4.7 times 10 to the negative 4. 4.4 times 10 to the negative 4.
Okay. Let's pick on somebody here. Kenneth, did you do this one? Number 4?
Yeah.
Which one? Let's see. That said circle the lowest pH. So that means, do you circle the biggest KB or the smallest KB?
The smallest.
Smallest, because low pH means very acidic. Good. So he's telling you to circle the smallest KB. So if you look at all those, Megan, which one is the smallest KB? No, yeah, the smallest KB. N2H4 is a 10 to the negative 6. So this looks like it's the weakest base, right? Everybody agree? This should be the weakest base. So it'll give the lowest pH, the most acidic pH. Good. So I would circle that one. And put a box around the one that have the highest pH. So the one that's the strongest base, Enrique. C2H5NH2. Yeah, I agree, right? Because 4.7 is bigger than 4.4. Yeah, so I'd put a box around that one. So that's how you play that game. The big test, get the big test accomplished, and you can get out of here. So highest pH, if you didn't quite catch this, highest pH means strongest base. And that means biggest KB.
I got almost, but just my things are way off. Like I got that number. It's
2.6 times 10 to the negative 27. So where did you
I
mess
don't know
up?
what I did. Okay, so I did pH. So I did the 10 to negative 10.25. And that'll give us, what will that give us? H.
That give you the H plus.
Okay, and then I have to square it. It's like when you do KC.
Yeah, you're skipping something in there.
Yeah.
You're skipping something.
What if we feel like you should do the 14 and then you get this and then you go to the 10?
No, don't we do this and then you square it like this, right?
But if you're just asking for the concentrate, oh, but you want the whole.
If they,
Remember? And then
Yeah,
you do it
okay,
like
okay.
this. Like this, right?
oh, you're getting closer. You're getting closer.
And then you gotta divide this by that.
But why are we writing this? So I think this is easier if you don't skip anything. Most everybody wants to jump to the x squared and stuff, right? So I think it's easier if you see the answer. And what I mean is if you write the KB reaction, because they're after the concentration of this stuff. So you really need an E row. You really need an E row. So let's get an E row. We have to write ice. So we don't know what this is, right? Water's always dashes. That's probably how I would do the ice table, something like that, right? And then by them, I think a lot of you have figured out this part though. By them giving you pH, you know what? Well, yeah, you know OH, but you know what first? You technically know H, H plus. And if you know H plus, then you can get. Now you can. Then so you really know. Follow the logic. You know, if you know H plus, then you know OH. So if you know OH, then you know what? X. Then just substitute into your KB expression. There's only one unknown. And X is really tiny, right? So you just drop it. See what I'm saying? Now I would set up the KB expression. (1.4 times 10 negative 9 is x squared all over question mark. So, and you know what x is, so just solve for question mark. That makes sense? That's how I would do it. And we can drop the minus x on the question mark because it's 10 to the negative 9. It's just going to be some work to get that x, though.
I did that when I got 8.3.
So you get hydroxide, okay. So take this divided by that, and you have hydroxide.
Plug that in.
And then that's going to be your x. Then you have to solve for question mark. Hopefully you can get around 23 out of this. You do it right.
How is this supposed to be exact setup? Like what's going on with X? Because I have everything else.
Cool. So you have your hydronium, right? Now X doesn't make any sense to you unless you write a KB. Sorry, unless you write a KB reaction. That's the only way X makes sense to me. So X is hydroxide. X is also this conjugate acid. So the KB is going to be x squared over what we're looking for, concentration of this base. So you know how to get X, right? You get it from pH.
I already have this. Like I know what goes there. It's like I have this and then I put it in already.
Okay,
But
so square it,
Like it doesn't look
right?
to me.
And solve for this guy.
Like, it doesn't look
He goes up there, that goes down there.
Can't you take the 10.25 and subtract it?
From 14 and get POH. Yeah.
And that'll give you OH.
10 to the negative POH is hydroxide.
Okay.
That's your X though.
Yeah, and that's my X, and then I plug it in myself.
Mm-hmm.
Butterfingers, I'm just kidding.
Squared over question mark.
So Dr. Smith,
Hmm? Why wouldn't we? This is Texas. School is never canceled in Texas. Ever.
Sorry, did we leave? Finish it?
Did you get 23?
Yeah, I forgot what I was doing wrong.
All right. You got 23? You guys got 23? You got 23?
Yeah.
Oh, the test! You guys, the test!